Okay, welcome back, guys. This is our next lesson. Okay, we're going to start talking about absolute value. Now, before we jump into the actual note section of this lesson, what I'd like to do is just talk about what does an absolute value graph look like, and that's going to help us visually see what kind of answers we're going to get with these equations. Okay, so here it is. What does the graph of the absolute value look like? I have a blank grid and I have an XY table here. Okay, and we're just going to go ahead and fill it in. And we're going to go from -3 to 3. All right, so here we go. And from what you've remembered previously from your other math courses, absolute value takes any number that's inside of it, okay, and it pretty much makes it positive, right? If I put a 5 in there, I get a 5. If I put a -7 in there, I get a -7. Or I'm sorry, I get a +7. Okay? So if I plug -3 into here, I get a 3. -2, I get 2. Then 1. Plug 0, I get 0. And then these guys don't change. They're already positive. They're going to stay positive. Okay? Now, let's go ahead and graph these points. So -3, 3. Then -2, 2, -1, 1, 0, 0. And the other side, exit. Okay, looks like this. So an absolute value is a V-shaped graph. Okay, notice there are no values that are negative for the y's, right? Everything's positive for them. Okay, we have positive y values here. Now, could we change the position of this guy? Yeah, we definitely could. And we'll talk about that in a transformation section. But for right now, this is a V-shaped graph. And there's one other thing I want you to notice. You see how some of the y values are repeated here? So for instance, if I want an output of 1 in this function, if I want an output of 1, there's 2 inputs that give me that, -1 and 1. Okay? If I want an output value of 3, there's 2 input values that give me that, -3 and 3. So when we're doing absolute value, we could potentially have 2 solutions to it. 2 solutions to an absolute value, I'll abbreviate, absolute value equation. Okay? We could. It depends on the equation. We could come up with an extraneous solution. We'll talk about that. But looking at the graph itself, you can kind of see where if I want the output of 1, well, I have 2 options that give me that. Okay? So I have to look for multiple solutions possibly. Okay? So let's go ahead and dive into this. Just put this away. Okay. And me with technology, I hope this works. Oops, nope, wrong room run. Nope, wrong room number. Come on. Some other teacher is probably wondering why the code's popping up on their screen. Oops. Okay, here we go. So, this is the absolute value part of it. So if you want to title it absolute value, you can. It's just a continuation of the previous lesson for solving equations. And that's what we did. Now we're going to evaluate expressions with absolute value, and we're going to solve those equations as well. Okay? So looking at different types of vocabulary, the 2 that we're going to, I don't know if it'll be new to you or not, but we're going to talk about the empty set of solutions, okay? Which, if it's empty, then you can probably imagine there's no solutions in there. And an extraneous solution, which is pretty much a fake answer. Okay, it's one way of stating it. All right, so here is the official definition for absolute value, okay? Just kind of in words, but what I want to really focus on here, just to simplify it, absolute value is a number or a value and its distance from 0, okay? And that's pretty pretty important. So absolute value is just distance. Okay, distance from 0. Okay, that's the key part I want to really get out of this. Okay, so for instance, they give us a little example. -4 and 4 are both a distance of 4 units away from 0. Okay, so remember looking back at the V-shaped graph. Okay, pretty much we're looking the distance from 0 from that V-shaped graph as well, but we have to look at different sides of the number line, left and right. Okay, so not only is, for example, 5 units away from 0, but -5 is. That's why absolute value is never negative, because we're talking about distance. Okay, and because of that, we are never going to have a negative distance. Sorry. Okay, never a negative distance. So a lot of times people say, well, why did we, plug a negative number, we get a positive? Why does this even exist? It exists because we're talking about distance. Okay, and there are different numbers who have the same distance, but we know that you can't have negative for that. So that's where it comes into play. So technically, I'm multiplying by a -1 to make it positive. All right? So let's start with a problem. Okay? So we have here y plus 3 in the absolute value equals 8. Okay? Now, what I'm going to do just for the first problem, so that way you have it, here's what it equates to in words. And I'm going to erase it up here because I'm not going to have enough space on this board. So in words, okay, it is the distance of the value y plus 3 from 0 without regard to direction. That is what that equation is translated. Okay? And hopefully it's not out of zoom from the video. It is the distance of a value, y plus 3, from 0 without regards to direction. That without regard to direction means I can approach this from the left side of the number line or the right side of the number line. Okay? Now, could we solve this without doing anything algebraically? Absolutely. What number can I add to 3 to get me 8? 5. What other number could I add to this to get to 8? Well, I'm thinking -11. -11 plus 3 is -8. Absolute value of that gives me 8. Gives me a distance of 8. Okay? So, when you're looking at this, okay, how do we approach this algebraically? Well, we already know from the graph and what it looks like visually, we technically have two problems here. We have y plus 3 equals 8, a distance of just normal 8. And we also have this guy equal to -8. We're looking at the other end of the number line, okay, with perspective here. So remember, without regard to direction, the only time we do is we're actually solving it algebraically. So we're looking from the right and left of the number line. Now we solve each one. Subtract 3, we get 5 for our first one. Add 3 to both sides. Okay, oh, not add 3. Subtract 3 from both sides. I get -11. So those are my two numbers. Okay. So when I plug these in, I get a distance of 8. And we can always check, and I kind of already did at the beginning when we guessed. Okay, but if you take a look here, what I have in the PowerPoint, okay, what number gives me that distance of 8 when I plug it into the expression? 5. 5 will give me that. Okay, and then on the other side of the equation, if you look at it from a different direction, -11 will give me that same result. All right. So my solutions for this guy, that is a weird looking set of brackets, sorry. I think that's a little better. Is 5 and negative 11. Now, why do I have the brackets? This is just set notation. Okay? That's all this is. 2 sets of nice little curly brackets with your numbers listed in there. Okay? Now, since this is a finite, set of solutions, leave it like this. If there are infinitely many, there's a different way of writing it, and we'll talk about that in the future. Okay? All right, let's do another one. Next example. Okay, what is the solution to this equation? Okay. All right, so if you want to write it in words, let's get rid of one thing. Let's change this guy to 2x plus 5. Okay. So now we're trying to find numbers that give me a distance of 15 when I plug in this expression. Now, could you still do this without doing this algebraically? You could. But we can do this algebraically. So we got 2 equations to consider. Okay, the one that didn't change, the normal method, and the other one looking at the different side of the number line, negative 15. Okay. Now, multi-step equation, technically a 2-step equation, means the same thing. Subtract 5, we get 2x equals 10. Once I'm done dividing by 2, I get x to be 5. Should we check our answer? I think we should. Plug this in. 2 times 5 is 10. 10 plus 5 gives me the 15 there. Okay? Phone's ringing. I'm tempting not to answer it right now. Okay? Now over here, we'll subtract 5 from both sides. We get 2x equals negative 20. And then divide both sides by 2, we get x equal to negative 10. So if I plug these numbers in, it'll give me that distance for me. Okay? Now, one thing left is we should write this in set notation. So here you go. Technically, I tell you what, I should be right with this. Put your negatives first, then positive. Just like on a number line, right? You go negative to positive. When you're writing set notation, negative to positive. Okay? There we go. So there's 2 examples like that. Not too bad, huh? So just when you're thinking absolute value, think of the graph itself, how it looks, and think about, hey, I could have 2 solutions here because I'm looking at, left and right of that number line. Okay. Now, when an equation yields a no solution, when it's never true, okay, what does it look like? Well, for absolute value, it's this. You can't take the absolute value of a number to get negative 4. Okay? For one thing, this is always going to be positive no matter what. Okay? But remember what absolute value means. It's the distance. So you're telling me the distance from this number x from 0 is negative 4. You can't have like negative 4 feet or negative 4 meters. It doesn't work, right? So this is what we want to avoid. Okay? If you see this with an absolute value equation, there's no solution. Now, how do you show this? Well, you can either give me an empty set of brackets using that set notation, or you can give me the little 0 with the slash through it. Okay? Sometimes this is also written as the null set. Okay? It means that there's nothing to satisfy that equation. So either this or just a little squiggly, but empty set of brackets to just show that it has no solution. Okay? Oh, there we go. So let's try this problem. I don't know if you could see this already. Maybe a little foreshadowing, but this won't have a solution. Why is that? Well, think about it. Anytime you have an absolute value equation that has stuff with it, like this plus 5 with this, right? We never encountered a problem like that before. Before I evaluate this, I have to get the absolute value by itself. Let me write that down. You want to always get the absolute value by itself. Because right now you're saying that this guy goes to 0. You know what I mean? You can't really evaluate something like that. So to do that, I'm going to subtract 5 on the other side. Watch what happens. I'm done. I can't do this. The distance this guy is from 0 is -5 is how that reads. I can't have negative distance. So this is a no solution problem. So no solution, so it's the empty set of brackets, or you can give them that null set symbol either way, okay, just to indicate that, hey, this is not going to work. There is no number that I can plug into here that gives me -5, because this is always going to give me a positive value. All right, so there's a nice little no solution. Now, what if you blindly went into this and you still set your 2 equations up, right? And you still kept solving. You're gonna, when you plug it back in to check, you're gonna see it can't work, okay? So no matter what, whether you realize it from here, or when you start solving it, you realize when you check your work, it's like, oh, wait a minute, those numbers aren't working. For a good reason. Okay, oh, and apparently I still kept that there. Okay, there we go. So try this one out. Another good example. Remember, you can always pause the video, and I hope that you are. I don't want to say that every video, since this is what, our 3rd or 4th one. So here's our options, and I'm sorry it did get formatting-wise. I'm trying with the PowerPoint. So what is the solution to this guy? Well, kind of obvious maybe in a way, because we just did a problem like this. This one will be a no solution. This is the correct option. Okay? All set. There's no solution that'll make this work. 2 ways to read this. 1, what's inside the absolute value is positive no matter what, right? You're adding another positive number to it. So no matter what, this side of the equation is always positive. It's bigger than 0. It's never going to equal 0, right? So you're done. You don't have to worry about it. Or you can do the subtraction yourself. I subtract -7 to the other side and realize, ooh, the distance is -7. That can't work either, okay? So this is a no solution problem for that guy. Okay. So just a little bit of vocabulary. A constraint is a condition a solution must satisfy, okay? That's what a constraint is. Now, even if the correct procedure, I hate when the phone rings when you're trying to, I will have to call them back. Even if the correct procedure for solving the equation is used, the answers may not be actual solutions to the original equation. Okay, such numbers are called extraneous. So, and this can happen in a lot of different cases, but let's say you solve everything to a T. You're like, hey, I followed step 1, step 2, I followed it exactly how it should be read. But something isn't right, and that can happen. That's why we always check our work. So when those numbers don't work in your equation, we'll call them extraneous, okay? So let's go ahead. I have 2 problems that work with this. We're going to solve both of them, and that'll be the end of the lesson. So here we go. Okay, we have 8 plus y equals 2y minus 3. Now, when you look at this, the absolute value is by itself, right? I don't have to move anything on this side. So now what I'm going to do is I'm going to separate this into 2 equations. I have the normal approach, right? I don't really change anything. The other side, I make it the opposite. Now, you got to be careful, and I'm going to write this using parentheses just for now. And then once you solve more of these, you might not need it. I'm going to take the opposite of the whole entire expression. I want the opposite of everything here. If you put the negative on the 2y, well, you didn't take the opposite of negative 3 yet. So it's the opposite of everything. Now, on this side, we'll solve it. Okay, we'll just combine the y's together. 8 equals y minus 3. Add 3 to both sides. Y equals 11. Okay, so 11 will satisfy that. Now over here, I'm going to distribute the negative. So negative 2y plus 3. Okay. Then combine like terms here. I don't know. I like keeping the variable positive, so I'll add 2y. 8 plus 3y equals 3. Okay. Subtract the 8. 3y equals negative 5. So y equals negative 5 thirds. Okay. So these are my two solutions. But just like a good student, a good math student, I should check to make sure that these actually work. Okay? So here's the slide, and please pause the video and copy this part down. Okay, I'm going to save myself in the marker for me writing everything. But here's what happens when you check your work. Okay, here's the first part. You plug 11 in. So 8 plus 11 gives me 19. Then on this side, we get 2 times 11, 22 minus 3 gives me 19. Does this actually become true? Yes, 19 equals 19. So that solution works. Let's try out the negative 5 thirds. So here's my original. I substitute those values. Inside the absolute value, I get 19 over 3. On the other side, I get negative 10 thirds minus 3. Okay? I come down to the very bottom. 19 over 3 does not equal negative 19 over 3 when I'm done simplifying. So, that solution didn't work. Okay? That's not giving me the correct values that I need. So when I go back to this guy, we're going to exclude this number. Okay? You can list it just for your own benefit and call this an extraneous solution. That is not a problem. And then our real answer is just one of them. It's 11. There's only one number that can give me the distance that's being projected here, and it's 11. Okay? So, anytime you have an absolute value problem, please check your answers, because this can happen. Okay? Alrighty. Last problem, and we are done, guys. That's pretty cool. Trying to keep the video of a good length, so that way you're not watching a long video. Okay. So once again, is the absolute value by itself? Yes. I don't have to move anything over to the other side of the equal sign. Break it up into your two cases. So here's case 1, where I don't change nothing, right? Case 2 is when I take the opposite of the other side, and I am going to fully write that out. And I suggest you do as well. Over here, we're going to go ahead and solve. I'm going to take 2x over to the other side. So x minus 5 equals 1. Add your 5. So my first possible case would be 6. Okay? Hopefully 6 would work. Don't know yet. We're getting there. Other side. 3x minus 5 equals negative 2x minus 1. So I took the opposite of everything in that expression. Just because of my preference, I'm going to add the 2x to keep the variable positive. It's just what I like. Add 5 to both sides. So, x is equal to 4. Oh, no, wait. I'm so sorry. I jumped the gun. 5x is equal to 4 there. I am so sorry. And divide both sides by 5. So x is equal to 4/5. So there's my second solution. Now, given what I just told you about extraneous solutions that can occur, let's check our answers. Okay? So check. So let's plug 6 in. 3 times 6 minus 5 equals 2 times 6 plus 1. Okay? Let's see if it works. 3 times 6, 18. Minus 5, 13. 2 times 6, 12. Add 1, 13. Absolute value of 13 equal 13? It does. Good solution. Nothing bad about it. Let's check the other guy. Check. Okay, so let's see how this goes. 3 times 4 is 12. So this would be what? 12 over 5 minus 5. I'll just simplify that part first. 2 times 4 is 8, so that's 8 over 5 plus 1. Okay. Got to find common denominators, so put these over 1 to make it easy. Common denominator is 5, so that becomes 25, right? So that would be what? Negative 13, if I'm correct with that, right? Negative 13, so that'd be 25. So negative 13 over 5. Okay. And then on the other side, common denominator is 5 again. So that'd be what? 13 over 5? So you tell me, does this work? Does the absolute value of negative 13 over 5 equal that? It does. Absolutely does. So my correct answer is both of these. So you can have 4/5 and 6. Both answers work. Okay. Any questions? Please speak up. Hopefully, this is bringing back some memories. If not, if this is something relatively new to you, well, welcome to the club. Okay, welcome to Absolute Value. If you have any questions, please let me know. But overall, just remember, absolute value is how far you are from 0. Absolute value is all about distance, so you can't have negative distance. And anytime you're solving these, just keep this in mind. Keep it in mind that it's a V-shaped graph. You could potentially have 2 solutions. That's why I put potentially here, right? Because you could have extraneous solutions. So at first, that might not have made sense at the beginning of the lesson, but hopefully now it does. Okay. So thanks for watching, and I'll see you guys in the next lesson.